Yes, thanks everyone. I also had some lunch. I had some vegetarian goulash. I think it should be forbidden to call that goulash if there's only potato in there. Okay, that's a vegetable stew and not a goulash. See? But anyhow, yes, 50 Shades of Kubernetes Autoscaling. As you already said, you always need a catchy title for a conference talk. I'm going to show you quite a few alternatives how we can implement autoscaling, workload autoscaling, as well as cluster autoscaling with Kubernetes. It's not going to be 50 different options, okay? It's probably only going to be 8, but that should also be enough. So yes, I'm Leander, nowadays Managing Director and CTO. I work for Kuaware. Usually we have been sponsors or had a booth here. This year, unfortunately, we don't. As you can see, I come from the very south of Germany, almost Austria. I live in a town called Rosenheim. Our headquarters in Munich. We usually do cloud-native application development and nowadays more and more platform engineering. So this is not my first container day, so let's sit in our DeLorean and ride back to the year 2017. That was my first container days conference where I had a talk which was called The Hitchhiker's Guide to the Cloud Native Stack, also a catchy title. And I talked about cloud-native applications and why we should build them and what are the benefits of cloud-native applications. Now, we're in 2023 now, and back then I talked about anti-fragility. Okay, so you can build applications that don't break, that spin up fast again. And if you see in the cloud-native ecosystem nowadays, well, you know, good old circuit breakers, we have service meshes, different options, we have chaos engineering, all of these disciplines kind of evolved and pay into that anti-fragility bit. I talked about continuous delivery in DevOps. And obviously, there are loads of tools and technologies out there to implement continuous delivery and DevOps methodologies. You have GitOps tools, you have Argo, you have Flux, you've got different things. Also, OpEx savings I talked about, and OpEx is operational expenses. So the idea was that if you build cloud-native applications compared to traditional data centers, you can save a lot of money. I think that one didn't work out quite that well because we all know the cloud also costs money, but we have a whole new discipline there, FinOps, right? To kind of that helps you to save money and scale down on your expenses. And the fourth one was something called hyperscale. Nowadays, we're in a digital era. We build applications that provide valuable digital services. And hyperscale, the idea was that the applications we build nowadays, they see a lot more traffic than they used to have, a lot more data, they have to process a lot more data, they have to handle a lot more data, and maybe a lot more features. So how can we actually build hyperscale applications? Because this is no free lunch, right? You have to do something to have a hyperscale application. And basically, this hyperscale thing has to do with elasticity, right? Elasticity is like you want to scale out and you need to scale in again. It's like this rubber band, it goes in both directions. And you need elasticity for your workloads, obviously, hyperscale applications, but also for your cloud infrastructure and also for Kubernetes. Those three things are required to build hyperscale applications. So if you have this hypothetical 3-node cluster here, and we have our little purple microservice there, as more and more traffic maybe hits that application, Kubernetes, if you configure it correctly, will start to scale out the microservice. You have 3 replicas, even a 4th replica. And Kubernetes does a pretty good job in evenly distributing these things if you configure it correctly, obviously. So maybe you have that orange microservice coming also, more and more, right? Even more traffic, you need more replicas. And you can see the cluster now fills up more and more, right? We only have 3 nodes. Maybe you have a batch job here. Maybe you find out that batch job needs more resources. So what we've seen so far is like, scaling out, horizontal scaling. Obviously, also possible is the terminology called vertical scaling, right? You make the instances bigger, not more instances, but bigger instances. Maybe more memory, more CPU. Maybe it's a big batch job, number crunching, things like this. You have a few of those. And now you can see cluster already pretty full. And let's say you have that big red, I don't know, probably some monolithic application, really big one, needing more resources, and unfortunately, it doesn't fit into the cluster anymore, right? So this is where now the cluster autoscaling comes into play. So if your cluster is full at that place, well, you need to spin up a new node, obviously. You need more resources. then you can place that big red monolithic application or whatever batch job. You can let it run. Kubernetes can schedule that big red one again on node 4. Let's assume at some point that pod, that instance disappears because it did its job. Now I have a kind of an empty node, right? This is wasteful. Why should you have an empty node running around, lingering around? So you can scale in again. So as I said before, elasticity works in both ways. You have, scaling out, but also scaling in. And as the cluster starts working, what you can see is that at some point you will probably have some form of defragmentation. The old guys of you who know proper hard drives, like old times, right? Hard drives, when I say the word defragmentation, because we had to defragment our disks. So that kind of may happen to a cluster as well. So what you would also need in this scenario is some form of scheduling to kind of compact your workloads to the minimum required resources of your cluster. So that would be ideal. Now, this is very, right, it's a nice drawing, nice picture. What do you need for that? And basically, you only need two things. You need events and you need metrics. This is the two ingredients you will need to implement different autoscaling strategies. As we all know, in a Kubernetes world, Kubernetes is kind of a huge distributed state machine. There are events everywhere, right? You have events for everything. Pod being scheduled, pod being started, container created, maybe pod evicted, node is full events. So events is pretty much what Kubernetes already brings out of the box. The other thing you need is like metrics. So think of metrics is like the standard metrics, maybe CPU usage, maybe memory, but also requests per second, for example, or number of messages in a message queue could also be a metric, right? So you need different metrics to implement different scaling strategies or scaling algorithms. On a high-level view, this is what it actually looks like. How does application scaling in Kubernetes work? Well, in the middle, you have some sort of metric registry. This is what you can query for what's the CPU usage of this process or this pod, what's the memory usage, how many requests per second are here at that API gateway. So these are the different metrics. You have some sort of autoscaler that continuously queries that metric registry, does some magic calculation, and based on the outcome of that calculation, the autoscaler will then scale the application up or down, right? If there's more traffic, then maybe the autoscaler will decide, hey, I need more resources or I need more pods, more instances of that application, then we'll spin up more applications. And when it decides, okay, I have way too many replicas for this actual traffic or for the actual resource usage, then it may also decide to scale the application down again. Now, the metrics registry, if you double-click on that one, you see that nowadays you have 3 different types of APIs you can use. And I'll show you some YAML later on with the demo. You have the resource metrics, the so-called custom metrics, and the external metrics API. So the resource metrics, that is kind of the old metrics API that has always been there. This is CPU and memory. With custom metrics API, you can now query additional Kubernetes object-related metrics, maybe the packets per second on a pod arriving or something, right? And the external metrics API, this is probably the most powerful one, is that it provides you the mean to query other sources. You may have a Prometheus installed in your cluster. So using that metrics registry or the Kubernetes metrics server, the Kubernetes metrics server can then query onto a Prometheus, for example. So all the metrics you would have in a Prometheus are now available as metrics for autoscalers to decide if you want to scale up or down. Right? So this is then another double click if you want. So you see here, the resource metrics is the metric server that collects its metrics from the C-advisor. And in a Prometheus world, you have a Prometheus as external metrics plus the Prometheus adapter. Of course, you have to install these things in your cluster, right? And I'm going to show you in a minute. So everything I show you now, because I'm pretty much done with the slides and the rest is demo, is in that repository. So feel free to clone and play around with that repo. So let's go here. I hope it's big enough. I think so, right? Thumbs up, big enough? Excellent. So that's the repository. So if you want to play around, there's a nice makefile in here. I have 2 clusters currently running. One is running in the Google Cloud, and one is in AWS. So if you want to spin these things up, I've already done that, then you can say make create GKE cluster, and then you wait 5 minutes, and you have a cluster running. So right now, that's a 1.26 cluster, 1 to 5 nodes. I enabled autoscaling for this one. I'm going to talk you through this in a minute. Also, what it does, it will use Flux to install a few additional infrastructure components. It will install a monitoring stack, so the cluster will have first up the metric server installed, and also Prometheus, plus the Prometheus adapter installed, I showed you before, and a few other things. So let's go to our README file. So this is the first thing to make use of the custom metrics API and the external metrics API. So what you need up here, what you could do is you can use the Helm chart to first install here in line 15 the Kubernetes stack, and then another chart to install the Prometheus adapter. So this is pretty much all you have to do to make use of all those 3 metrics API to then, for example, configure your horizontal port autoscaler to make the scaling decisions on that one. Right, so here we have the horizontal one. This is usually what you have to configure. So let's say I have this PHP Apache deployment in my cluster running. What I can do with this so-called horizontal port autoscaler, I can say, well, this HPA, this is the scaling target. So please scale the PHP Apache deployment. Minimum replicas 1, maximum replicas 10. And please do that on the resource CPU. So if the average CPU utilization over all the instances is above 50, the autoscaler will start to scale up. If it's below 50, then it will start to scale down again, so that it kind of hits this average utilization pretty much. What you can also configure is kind of different scaling behavior. So how should it scale up and how should it scale down? You can specify stabilization window in seconds, for example, here. You can define with that policy here how aggressive it should be or how slow or fast it should be when it does the scaling. So let's do that for a minute. So I've already configured those things here. Now, let's see if we do that here. What's the time? Time looks good. So we see here, that is at the moment the HPA for the PHP Apache. You see that right now it's only using 1%. So let's see what happens if we put on some load onto that system. Let's see. Connection refused. Shouldn't be there. It's always good with the demos, right? So let's see. Come on. Let's give it some more time. I do have internet, right? I do have internet. So why is it my demo is not working? Am I in the right? Oh, no. Now, finally, it's producing something. OK. Whew. So this will produce some load now and issue GET requests onto our PHP Apache. And at some point, I hope that here we will see different values, especially there where it's unknown at the moment. So let's see if it's known at some point. So, right. Let's open another one. OK, get parts. So let's see. So at some point, it should decide, hey, this one here is not enough to kind of handle the load. And it should start, hopefully, if the demo works, to spin up things. Oh yeah, see here, so the HPA now decides, oh, we have 252%, the average should be 50, so now the HPA should start to create more instances, okay? So this is pretty basic, right? Horizontal pod autoscaling at work. So now it's container creating, and at some point, if we, well, kill that stuff, obviously, then this one here should realize, okay, it should go down again, and then it will stop processing again. So we just scaled from 1 replica to 6. Now we stop the load. So at some point, the autoscaler should decide to terminate things again, right? Basic. Okay, now, Prometheus. To just give you an idea what the other APIs look like. So what you could do, for example, this is now leveraging the custom metrics API. So maybe you decide to implement your scaling based on the packets per second. Or maybe you decide to implement your scaling on the requests per second on your ingress. Also possible, right? So more connections, more requests per second means, well, there's obviously more load, you could scale up. So this is what the custom API looks like. And if you have the metrics adapter and the Prometheus metrics adapter installed, then obviously what you can then do is here under type, you can leverage the external metrics API. Also, maybe you decide you go for queries per second or something. And down here under source, you would now then configure, hey, where is my Prometheus? What's the metric name? And what is the selector? So basically here, in here, you can then issue or write down your Prometheus query to get the value and then use that value from your Prometheus to decide on your autoscaling behavior. So that's all pretty simple. So that's the horizontal pod autoscaling done. So for workload. The other type of scaling I showed you definitely was the vertical pod autoscaling. VPA, as you know, well, VPA basically says, well, are the resources enough? And if the resources are not enough, then please provide and kind of adjust the actual limits of your pod, kill the pod, increase those values, and then spin up the instance again. So how does a VPA look like? Well, pretty similar to the HPA. Again, you have to configure the target. Then you have a so-called update policy, right? So the VPA can work in different ways. It can work kind of in the automatic mode, kill the stuff, adjust the limits, spin the pod up again. What I do now here in the update mode, I set this to off. That means the VPA is in recommendation mode, so it will only tell you, hey, that resource, that pod, that hamster deployment here, it should use or it will use or it should be set certain limits and certain resources. So this is actually pretty good to auto-tune or not auto-tune, to tune the resource requirements of your deployments, right? I mean, I'm usually a Java developer. How do you determine the limits and the requests of your application? When you're in development, it's usually, well, let's give it 4 CPUs and 2 gigabytes of RAM should be enough for a Java application, right? And then you write that down in your YAML and you never touch it again. Also pretty wasteful, right? Also from a sustainability point of view. So what you can do is you can use the VPA to tune your applications to use the right amount of resources and only the amount of resources required. So what you usually have is the VPA, maybe you have a good load test, right? You let the load test run. After that, what you can do is you can say, describe VPA, hamster VPA, up. And this is then actually the recommendation, what it says. So it tells me, well, you should configure the lower bounds and the uncapped targets and the upper bounds to lower bound CPU, maybe half a CPU, up to 1 CPU, and also the memory. If you install a tool called Goldilocks, then you have a nice fancy UI for that, for the VPA, that will now tell you for exactly that deployment how you should set your limits and your requests to either guaranteed quality of service or burstable quality of service. So I find that VPA pretty useful to kind of tune the resources, the requests, and the limits for CPU and memory to what you actually need. Okay, so HPA covered, VPA covered. Now, the next thing is, now this is usually all pretty basic if you have Kubernetes. Now sometimes you need other metrics or you need other scaling possibilities and scaling strategies. So a technology or a tool that you should definitely put in your toolbox or maybe on your cluster is a tool called K8s. So K8s is, they call themselves event-driven autoscaling, right? So what they have is they have like 60 plus different sources that you can use to determine your scaling behavior. I gave the examples of messages in a queue, for example, right? If you have a message-driven application, the application only has to run if there are messages in the message queue, right? And if there are no messages to process, well, then scale down to 0. There's nothing to do. K8s, for example, has these different strategies available for RabbitMQ, for Kafka, I don't know, for Nats. You have S3, maybe number of files in an S3 bucket. If there are files to process in the S3 bucket, spin up your application, let it process the files. Once the files are gone, scale down the application again. So what K8s gives you is a lot more flexibility in implementing different scaling strategies to your application. And if you are a bit into green IT, that kind of leverages that you are not wasteful with the resources and not wasteful with your cluster. So only let your applications run if they need to run. So that's the basic idea. So let's say we deploy that one here. So let's see. So we created something, and I show you what you can actually do. Well, this, for example, here is a scaled object definition for K8s. This is here, for example, scale my deployment based on the cron strategy. What I just deployed here is I deployed a consumer that will consume messages from a RabbitMQ. And down here, what I say here with this scaled object definition is, well, again, here you see in line 39 and 40, you see the scale target ref. So please scale my RabbitMQ consumer. Poll every 5 seconds, cooldown period, things like this. And here is this the important bit, the trigger. So this will now say the trigger for the scaling for this scaled object is of type RabbitMQ. You give it the queue name, the queue length. So if the queue length of 5 is reached, then it will start to scale that deployment. So let's see. Okay, get parts. Okay. So as you can see, right now there is no RabbitMQ consumer running. So what we're looking for is that RabbitMQ consumer here. Now let's deploy a small job that will publish a few messages to a RabbitMQ. Let's see. Up. Okay, the deploy job created. Okay. And now you see here, it now, where is it? Well, it's already gone. This line here, right? Here is now the consumer that will start to consume the messages of the queue, because basically here was the publishing job, and now it will process those messages on the queue. Then the queue is empty at some point. Then it will wait a while, right? So that it doesn't continuously, create and kill and create and kill those pods again. So it will wait for the cooldown period, and then at some point, that RabbitMQ consumer should be shut down again by K8s because there are no more messages on the queue. So let's see, we wait maybe a few more seconds, and then at some point it should die again. All right, so this is horizontal, vertical autoscaling plus very flexible event-driven autoscaling. So that is for the workloads. So what we have not covered so far is, well, what do we do with the cluster? Now, there are definitely two projects, again, to put in your box. The one is, let's say, the default cluster autoscaler. That's an official Kubernetes project. I'll see here, starting a few consumer things again. So the cluster autoscaler is an official project from Kubernetes. Now, this thing now depends on the, let's say, the cloud provider, the Kubernetes provider you're with. Now, if you're in the Google Cloud, like this cluster here, well, configuring this one is pretty simple. What you see here in those in this command, if I want vertical port autoscaling configured, well, you need to specify that command line option. If you need horizontal port autoscaling configured, then you need those add-on. And for cluster autoscaling, everything that is required, if you use the CLI, I know this is not Terraform now, this is the easy bit. So all you have to say is -- enable autoscaling, and you can specify an autoscaling profile. And the autoscaling profile pretty much tells Google how aggressive it should scale the cluster up and down. If you say optimize utilization, this is kind of the most aggressive option you have. So as soon as a node is empty, it will pretty much kill it instantly, right? So maybe that's not a good strategy for production, right? So maybe the other option would be balanced, okay? So there it would wait like 5 minutes before it finally decommissions the node and kills it. So if, let's say we do that here, let's see how fast Google is. Let's see. So what's the time? 7 minutes. So we say that here. We create that one, K get nodes. Let's see. So as you can see, we at the moment have a 5-node cluster. So if we now scale that deployment to some insane scaled, right? Up. Inflate, K get ports. Oops, that was the wrong one. So what you see here now is you have those inflate things in pending mode. Now, pending is probably because there are not enough resources in the cluster available to kind of satisfy the request, the resource demands by this deployment. If we have a look at the events, it should actually also tell us something about these events eventually, right? Those are the other. Wait. Maybe we do that. Grab inflate. Yeah. So so down here, and at some point it should kind of realize, okay, up there you see port triggered scale up. This is the event that the autoscaler can now listen. So basically, we definitely need more instances to scale up. So let's see. At some point, we should get more nodes. Okay, get nodes. Right, and as you can see here, we now have a lot more nodes available. We started with 5. Now here we have like really young nodes, 62 seconds, 50 seconds. They're already ready. So this is why I like Google. It's the scaling up, and starting new nodes is really snappy. Now, talking about snappy, and that is then the last bit of the demo. Now, scaling in AWS can sometimes take a while with the default autoscaler. But there is a better option, and the better option is called Carpenter. So technically, Carpenter is also a cluster autoscaler, a generic cluster autoscaler, technically. At the moment, it will only work for AWS. And if you want cluster autoscaling in AWS, I strongly advise you use Carpenter and not the default cluster autoscaler, because Carpenter also is very, very fast. Now, what I've done to spin up that AWS Kubernetes cluster, I use a tool called K8s. I know, again, no Terraform, but who uses Terraform nowadays, right? No one uses Terraform anymore. So I have EU North 1, 124. All you have to specify here in this K8s, please also install Carpenter. You really have to watch out for the versions. So not every Carpenter version works with every Kubernetes versions. So you kind of need to make sure that the Carpenter version supports the Kubernetes version. So look at the README. And once you have installed that, you then need to configure Carpenter. And the basic configuration is done in this provisioner thing here. So what I tell him is, dear Carpenter, if you need to scale up the cluster, then please use spot instances. And this is super flexible, right? So the additional nodes you spin up if you have more demand can be of a totally different resource group, or in that case, instance type, okay? So with this provisioner, you can configure Carpenter, what type of nodes in what regions, what capabilities do the nodes have to have, and then it will find those nodes. You can specify limits. You can specify how long a node should live after it's empty. So here, again, I'm quite aggressive. So if a node is empty for more than 10 seconds, it will kill the node. So that is now time for our final. So I need to switch the cluster. So you see, I at the moment have a 3-node cluster. So this is the nodes and the usage of my nodes at the moment, right? So 3 nodes, not that full at the moment. And now I can kubectl scale deployment, inflate, maybe replicas 10. Bam, cluster full, almost full. Now what we well, there are, as you can see, there are a few pending. Now let's make even more, right? So K8s pods. So we should see a lot more pending resources. And now, fingers crossed, in, let's say, a few seconds, you see it started a totally different instance type up here, a C5 large or a C5X large, and not on demand, it's a spot instance. So this is the power of Carpenter. It will really spin up nodes very, very quickly, also in an AWS world, to satisfy the resource needs of all my, of all my pods. So all the pods that have been pending before are now container creating, are now running. And let's say, and that's then the final closing bit, if I scale down to 1 again, boop, the cluster is empty. And let's count down from 10 to 1, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And now, come on, nodes, disappear. Yes, almost worked. Okay, so that was autoscaling in action. As I said, that was definitely not 50 shades, but maybe 8 different shades. We talked about Kubernetes metrics server. You need that. If you are in a Prometheus world, then you would probably leverage the Prometheus adapter for the Kubernetes metrics API. We talked about the HPA. We talked about the VPA. We briefly talked about KEDA for event-driven autoscaling. We talked about the cluster autoscaler in the Google world. We talked about Carpenter. Unfortunately, what we did not talk about is the Kubernetes descheduler, but that is kind of the project you need to defragment your cluster, to compact it again, so that, for example, the cluster autoscaler can do its magic and scale down again your cluster. All right, that was it. If you're into platform engineering, then give me a shout, okay? We are looking for platform engineers and QA and open for questions now.
Thank you so much, Leander. And we have, luckily, like 2 minutes left for questions. So I have 3 on Slido. So let's put them on the screen. And then we start with the first one, which is, what suggestion for stateful applications do you have that might lose data on scaling down?
Well, you shouldn't. I mean, you have to park your state somewhere, right? I mean, either you have a database or you have maybe you use some in-memory solution, right? But keep the state out of your replicas. I mean, that's a secret, right, for those things. You should not build stateful applications anyway, but I know in reality you will always have state, but you have to put it somewhere into some available solution, maybe an in-memory data grid or a good old plain database.
Thanks. And then the next one. Most of cloud-native solutions do have a Prometheus exporting mechanism like RabbitMQ. Do you recommend to use SCADA or the Prometheus metrics for those?
Well, to be honest, I will not recommend either of it. I mean, again, not every installation is the same. If you already have Prometheus on your cluster, then I would recommend, reduce the complexity, try to stick with Prometheus and try to see how far you come. And once you need more elaborate scaling solutions, then maybe switch to Kida then altogether. Yeah. But I would not use both from the start, right?
Good. So and then the last question is about Java applications. Or legacy Java application pods either take multiple mints to become ready or use fraction of the requests after becoming ready. Is rewrite the only option?
No, of course not. You can come to me and we have a chat about that because this is what I'm actually an expert in. But obviously, rewrite is sometimes the only option. Maybe you need a more sophisticated framework. Maybe you migrate to Quarkus or something. But obviously, you have to do something about it and maybe split it. So you have to re-architect it. Let's say re-architect, maybe not rewrite.
Thank you so much for answering the questions. And thanks to the audience for putting the questions on Slido. And I'm going to let you go now to catch your next session. So give it up once more for Leander.
Thank you.